Every time you switched on a light in 20th century Britain, the chances are the power reaching it had passed through a machine built by C.A. Parsons. The turbines that drove the national grid were designed and built in a single works in Newcastle on Tyneside. At its peak, Parsons employed more than 7,000 people across a 100-acre site, and its machines lit homes and cities across Britain and the Empire. The firm survived 2 world wars. It survived the Depression. It survived the loss of its founder and went on to build the most powerful turbine generators on Earth. And then, after more than a century of making, the great works on Shields Road fell quiet, and the turbine building left Newcastle for good. How does a company that powered a nation and survived everything the century could throw at it simply fade from the place that built it? What really happened on Tyneside? Chapter 1. The Shy Earl's Son. It begins on the Tyne, but the man who would electrify Britain wasn't born within 100 miles of Newcastle. He was born in the Irish Midlands, the youngest son of an earl, and he spent his boyhood in a workshop most aristocratic families would have found beneath them. His name was Charles Algernon Parsons, and he came into the world on the 13th of June, 1854. His father was William Parsons, the 3rd Earl of Ross, and the family seat was Castle in County Offaly. The Earl was no idle landowner. He was an astronomer, and in the castle grounds he had built the largest telescope on Earth, a vast iron tube slung between 2 stone walls, known across the scientific world as the Leviathan of Parsonstown. For 3/4 of a century, it was the biggest telescope ever made, and it had been designed, in part, by Charles's mother. Mary, Countess of Ross, was an accomplished blacksmith and one of the pioneers of early photography. She helped design and finance the great instrument's supporting framework. This was not a household where a boy was sent away to be polished into a gentleman. The Parsons children were taught at home by private tutors who doubled as the Earl's practical assistants in his astronomical work. Among them, John Purser and a young man named Robert Ball, who would one day become Royal Astronomer of Ireland. And Ball noticed something about his youngest pupil. The castle workshop, he later wrote, was the constant resort of the Honourable Charles Parsons. While other boys his age were learning Latin verbs, Charles was building things: an air cane, a sounding machine, a working steam engine. And in 1868, when he was just 14 years old, he and his brother built a steam carriage that ran, with a cardan shaft, a bevel drive and a gearbox, decades before anyone had heard the word motorcar. He was a strange boy, and he became a stranger man. Shy to the point of pain, self-contained, almost incapable of expressing what he felt. His biographers struggled to capture it, an air of self-effacement, an exaggerated and wholly natural modesty that puzzled strangers as much as it endeared him to his friends. His own wife would say, of their early married years, that Charles had the reputation of being an extraordinary and weird young man socially, but that everyone understood he was a great genius. He would hold more than 300 patents in his lifetime. Engineers would come to rank him with James Watt, and yet he never became a public figure, because he could not bring himself to perform the part. He read mathematics, first at Trinity College Dublin, then at St John's College Cambridge, graduating in 1877 with first-class honours, and then he did something that astonished his family. An Earl's son, fresh from Cambridge with a first, chose to become an apprentice. Not just any apprentice. He went to the Tyne, to Sir William Armstrong's enormous works at Elswick, already the dominant industrial force on the river, and signed on as a premium apprentice, learning the trade with his hands. From there he moved to Kitson and Company in Leeds, where he worked, of all things, on rocket-powered torpedoes. And then, in 1884, he took a junior partnership at Clark, Chapman and Company of Gateshead, and was put in charge of their new electrical department. He was 30 years old. He had a workshop, a problem worth solving, and the most unusual education in British engineering. What he did next would change every home in the country. Chapter 2. Splitting the steam. The problem was steam, and it had defeated everyone who'd tried it. For 2 centuries, engineers had used steam by letting it push a piston back and forth. It worked, but it was a clumsy way to turn heat into motion. All that reciprocating weight, all that wasted energy. The obvious dream was a turbine, a wheel spun directly by the steam, smooth and continuous. But there was a catch that nobody could get past. Let steam expand through a single stage and it reaches a velocity so violent it would tear any wheel to pieces. The very force that made it useful made it impossible to harness. Parsons saw the answer where others had seen only the obstacle. If a single drop in pressure produced a destructive speed, then he would not allow a single drop. He split the fall in pressure into many small steps, a long series of bladed wheels, one after another, each taking only a little energy from the steam, so that nowhere in the machine did the steam ever move fast enough to do harm. His first compound steam turbine, built in 1884, was a small thing. It produced about 10 horsepower, spinning at 18,000 revolutions a minute, a speed nothing else of the age could survive. And it drove a dynamo he had also designed himself, because no existing dynamo could keep up. It was barely 1.5% efficient. It generated about 7.5 kilowatts. By any measure of raw power, it was almost nothing. It was also the beginning of cheap, plentiful electricity for the entire world. But his partners at Clark Chapman wouldn't fund the work he knew it deserved. They couldn't see what he could see. So, in 1889, Charles Parsons did the thing that built the legend. He left. He walked out, taking 12 employees with him, and set up on his own in Heaton, just east of Newcastle, under the name C.A. Parsons and Company. The first works covered about 2 acres, a single workshop, a pattern shop, a smithy, a test house, and an office. 48 people, all told. From this, the cathedral would grow, and then came the cruelty that nearly finished him before he'd started. When Parsons left Clark Chapman, the firm kept the patents. The patents on his own turbine, his own best ideas, belonged to the company he'd just walked out of. The inventor of the steam turbine was forbidden to build the steam turbine he had invented, so he built a different one. Locked out of his own design, he developed a radial flow turbine instead, where the steam moved outward rather than along the shaft. It was harder, and it was inferior, and he made it work anyway. The first examples, 3 sets for New Scotland Yard in 1890, produced 16 and 32 kilowatts apiece. He spent 5 years designing around his own genius. In 1894, he finally bought back the rights to his axial flow patent and returned at once to the better machine. There was a second venture, begun the same year he founded the works. Parsons set up the Newcastle and District Electric Lighting Company, the locals called it Disco, and in 1890 it opened Forthbank's Power Station. It was the first power station anywhere in the world to generate public electricity using turbo generators. The thing he'd built in a corner of a Gateshead workshop was now lighting a city. He didn't do it alone. Among the men who joined him was George Gerald Stoney, a fellow Dubliner who started in the shops as a fitter, took charge of the mirror department and the test house, and rose to become chief designer. Stoney would be one of the original crew of the boat that made Parsons famous, and, in the end, its last survivor. Because the turbine wasn't going to stay on land. Chapter 3. 34 knots. In 1894, Parsons formed the Marine Steam Turbine Company and ordered a boat. She was built at Wallsend by Brown and Hood, 44 feet of light steel, slender as a knife, and they called her Turbinia. She was an experiment with a hull, and almost at once she revealed a problem nobody had a name for. When Parsons first ran her, she wouldn't go fast. The propellers spun furiously and the water around them simply boiled into bubbles, robbing the blades of their grip. He had discovered cavitation, the way a propeller, turning fast enough, tears the water apart into vapour and loses all its bite. Nobody understood it. So, Parsons built the world's first cavitation tunnel, a tank in which he could study the phenomenon at leisure, and worked out how to beat it. The solution was extravagant. 3 turbines, driving 3 separate shafts, each shaft carrying 3 propellers. 9 propellers in all, on a 44-foot boat. And when he opened her up, Turbinia reached over 34 knots, making her, by a comfortable margin, the fastest vessel on the face of the earth. He now needed the world to notice. And on the 26th of June, 1897, the world was conveniently gathered in one place. It was Queen Victoria's Diamond Jubilee, and the Royal Navy had assembled at Spithead for a fleet review. Lines of grey warships stretching to the horizon, the Prince of Wales aboard, foreign dignitaries watching, the Lords of the Admiralty in attendance, and into this stately procession, between the anchored lines of the most powerful navy on earth, came a small steel needle trailing a plume of spray, travelling faster than anything anyone present had ever seen. Turbinia tore through the review at over 34 knots. The Navy's fastest picket boats, sent to chase her off, could manage about 27, and she left them standing. The Times called her speed simply astonishing. History has never quite agreed on whether the run was permitted. The popular story is that it was gloriously uninvited, an act of cheek that no admiral had sanctioned. But one man aboard, George Baden-Powell, claimed afterwards that the admiral of the fleet had quietly approved the demonstration, hoping to impress Prince Henry of Prussia, the Kaiser's brother, who was watching from a German warship. Both versions survive. Either way, the message landed. The age of the turbine had arrived, and it had announced itself by outrunning the Empire's own fleet. The Admiralty was convinced almost overnight. Parsons built the engines for the first turbine destroyers, Viper and Cobra, both launched in 1899. Both were lost in accidents within 2 years, but never through any fault of their engines. The first turbine merchant ship followed in 1901, the first turbine liners in 1905, and then, in 1906, the turbine went to war on the grandest scale of all. HMS Dreadnought, the battleship that made every other battleship in the world obsolete, was driven by Parsons turbines. So, soon after, were the great Cunard liners, 73,000 horsepower in each of Mauretania and Lusitania. On land, the numbers climbed without pause. His first megawatt machine went, of all places, to Elberfeld in Germany in 1899. A single contract that made his reputation across Europe. 1,000 kilowatts by 1900, 25,000 by 1912, the largest in the world, built for Chicago. 50,000 by 1922. At the turn of the century, the Heaton Works was turning out as many as 50 turbines a year, but the man at the centre of it was paying a private price that the public scale could never show. Parsons had married Catherine Bethel in 1883, and they had 2 children. Their son, Algernon, known to everyone as Tommy, apprenticed in the Marine Division and joined the board, the heir to all of it. On the 28th of April, 1918, Tommy was killed in action in Belgium, a major in the Royal Field Artillery, and the line of succession Charles had imagined simply ended, and there was a daughter. Rachel Parsons was one of the first 3 women ever to study mechanical sciences at Cambridge. When the war took the men away, she had stepped into Tommy's place as a director at Heaton, supervising hundreds of women building turbines and searchlight equipment. She was brilliant, and she had proved it. But after Tommy died, Charles would not let her continue as a director. The works would not pass to a daughter. It broke something between them that never healed, a rift that lasted the rest of their lives. Rachel went on to found the Women's Engineering Society with her mother and became its first president. The firm that bore her family's name carried on without her. Charles kept building and kept being honoured for it. The Franklin Medal, the Faraday Medal, the Copley Medal. He died on the 11th of February, 1931, aboard the steamship Duchess of Richmond off the coast of Jamaica. There was a memorial service at Westminster Abbey, and he was laid to rest in the quiet Northumberland village of Kirkwelpington. He'd built a machine that lit the world. He never learned to enjoy the fame it brought him. The works he left behind was about to enter its greatest years. Chapter 4. The Cathedral of Heaton. When Charles Parsons died, the 2 acres and 48 men he'd started with had become 25 acres and 1,800 people, and it kept on growing. Through the Depression, through another war, through the long, grey post-war years, when Britain rebuilt itself out of rubble and rationing. Between 1945 and 1960, the company grew 3-fold. The man who drove that post-war surge was not a Geordie at all. He was Australian, and he had started at Parsons the way thousands of Tyneside men started, on the floor, with a toolbox. Sir Claude Gibb joined the firm in January 1924 as a fitter on £2.15 a week. Within 5 years he was chief engineer and a director, appointed, it's said, by Sir Charles himself. During the Second World War, the country borrowed him. He became the Ministry of Supply's Director General of Weapons and Instruments Production, and then of armoured fighting vehicles, driving the development of the Centurion tank. And in September 1945, he came home to Heaton as chairman and managing director. They remembered him for his amiable pugnacity and for the fact that he never lost his love of the shop floor. He'd come up from it, and he never forgot the smell of it. And it had a smell. To walk into the Heaton Works in its prime was to be hit by all of it at once. Hot oil and scorched metal, the particular tang of the foundry, the steam, the tea stewing in the canteen. The noise arrived before you reached the gates, the baseline thunder of heavy engineering, the clang of metal on metal, the high whine of the turbine sets being run. The works was a city of trades. There was the blade shop, where the precise little aerofoils that took the energy from the steam were made by the thousand. There were the fitting shops, the foundry, the tool room. There were the drawing offices, turbine on one side, transformer on the other, where designers bent over boards for years at a stretch. Men whose entire working lives were poured into machines they would watch leave on the back of a railway wagon and never see again. And there was the test house. This was the heart of it, the place where the whole purpose of the works came together. A completed turbo generator, a machine the size of a railway carriage, built to spin for decades inside a power station, was run there under steam before it was allowed to leave. They would bring it up to full speed and load it and listen to it, the way a doctor listens to a heart, and only when it had proved itself would they take it apart, crate it, and send it out into the world to do its work. In 1957, the company opened its own mechanical engineering research laboratory, because by then the questions Parsons engineers were asking had outrun the textbooks. The people who did this work tended to do it for life and to hand it down. 3 generations of the same family on the same site was nothing remarkable at Heaton. John Donald Corney apprenticed there in the 1950s. John William Corney rose to become works director on the marine side. Names like these run through the firm's records in their hundreds. Fathers and sons and grandsons, the same surnames recurring in the blade shop and the fitting shop across half a century. That was the works. But a works that size was never just a works. It was the engine of an entire quarter of a city, and the city had grown up around it. Chapter 5. The town the turbines built. Along Shields Road, the works set the rhythm of life. The streets of Heaton and Byker emptied towards the gates in the morning and filled again at the end of the shift, and everything in between. The pubs, the shops, the cinemas, the churches, the long rows of terraced houses existed in the gravitational field of the factory. Men drank in the Raby and the Heaton Hotel. They were married out of the local churches, and they sent their sons back through the same gates they'd come through themselves. With the shipyards down on the river and Rayrol making switchgear at Hebburn, Parsons was one of the great pillars holding up the economy of the whole North East. The firm knew what it was, and it recorded itself with pride. After Sir Charles died, the company began publishing the Heaton Works Journal, conceived as a tribute to him, and it ran from 1932 to 1970. It documented the departments and the people in extraordinary detail, and when the Second War came, it carried rolls of honour that named the firm's own men one, by department and by regiment. Men from the blade shop, men from the fitting shop, men from the foundry, the tool room, the drawing offices, listed as their own, mourned as their own. The pride went all the way to the top of the social order. When the Prince of Wales visited in 1923, the crowds packed Shields Road so densely you could barely move, and Sir Charles himself, shy as he was, walked the future king through the works and introduced the men who'd been with him since the founding, workers with 30 years and more on the clock. In 1951, the company finally pulled down the original 1889 workshop, the little building where it had all begun, and put up a modern multi-storey block in its place. The firm had outgrown its own birthplace, and the machines that left Heaton went everywhere. Parsons turbo generators powered the national grid itself, the thing that, more than any single invention, turned Britain into a modern country. When the world's first commercial nuclear power station opened at Calder Hall, it was Parsons that supplied the turbo alternators and the great gas circulating blowers that made it work. Bradwell, Dungeness, Heysham, Oldbury, Chapplecross and Hunterston in Scotland. The nuclear age in Britain ran, very largely, on Newcastle engineering. The exports reached South Africa and Canada and beyond. In 1951, a Parsons generator went to Ontario Hydro. In 1959, the firm opened a nuclear research centre at Heaton, which a few years later became an international research company under the chairmanship of Lord Fleck, with the formidable Monty Finiston as managing director. The place even shaped people who never worked a shift in it. The engineer Ove Arup came out of Heaton. So did the writer Jack Common. A quarter of a city built around a single firm produces more than turbines, and the firm was vast. The Institution of Mechanical Engineers records that the company's heyday came in the 1960s, when the factory employed more than 7,000 people across a split site covering 100 acres. Local memory puts the wider Parsons enterprise higher still, at something like 12,000. The exact figure depends on where you draw the line, but the truth it points to is simple. By 1964, the boys' workshop, with 48 men in it, employed 8,000. That was the summit. From the floor of the test house, with a new machine roaring up to speed and the order books full, there was no reason on earth to imagine it could ever be otherwise. But the men at the very top of British electricity had already begun to do the arithmetic that would undo it all. Chapter 6. The Summit. The early 1960s were the richest years Parsons ever knew, and they came courtesy of one enormous customer with a building program like nothing the country had seen. The Central Electricity Generating Board, the CEGB, was spending money on a scale that's hard to imagine now. In 1958 alone, something like 40 power stations were planned or under construction, at a cost in the region of £800 million. Britain was electrifying itself completely, and somebody had to build the machines at the centre of every one of those stations. Parsons was first in the queue, and the climax of all that building was a single staggering machine, the 500-megawatt generating set. The CEGB chose the station at Ferrybridge to trial the first 500-megawatt sets in the world, and Parsons built them. They worked. They became the industry standard, installed in station after station across the country through the following decade. Some of them ran for nearly half a century. A pair of Parsons 500-megawatt sets at Rugeley went into service in 1970 and were still turning in 2015. In the space of just 12 years, Parsons had scaled its machines from 50 megawatts to 550. No firm on earth was building bigger. This was the absolute peak. 8,000 people, the most powerful turbine generators ever made, leaving Newcastle on railway wagons to light the country. A century of accumulated skill in the blade shop and the test house, doing the most advanced work it had ever done. And here is the bitter thing. The thing that nobody walking the floor at Ferrybridge could have known. At the very moment Parsons stood at its summit, the seeds of its undoing had already been planted, not in a German boardroom, not by a foreign rival, but in the offices of its own greatest customer. The CEGB had looked at the British heavy electrical industry and decided there was too much of it. Too many firms, too many designs, too much capacity for the orders that would eventually come. It wanted to buy turbo generators of just 2 designs when there were 4 firms making them, and when the great home-building boom began to ease, towards the end of the decade, the industry would be left with far more capacity than there was work to fill. The men at Heaton were building the most powerful machines in the world. They had no idea they were standing on the edge of a cliff. Chapter 7. Too many manufacturers. In the 1950s, British heavy electrical engineering was a crowded, healthy, competitive thing. Metropolitan Vickers, British Thomson Houston, English Electric, Brush, Reroll, Ferranti, Crompton Parkinson, GEC, and Parsons. A dozen famous names, all of them building the machines a modernizing country needed, all of them confident the orders would keep coming. The trouble was that almost all those orders came from a single place. The CEGB was very nearly the only customer that mattered, and a single dominant buyer changes everything. It can decide, on its own, how many suppliers it wishes to keep alive, and it had decided there were too many. The board wanted turbo generators built to just 2 designs. There were 4 firms still offering the full range. The arithmetic was brutal and obvious. 2 of the 4 were surplus to requirements, and nobody at the top of British electricity was going to pretend otherwise. The first answer was consolidation, and the man who drove it hardest was Arnold Weinstock. Weinstock took over as managing director of GEC in 1963, and he set about reordering the entire industry with a cold, brilliant ruthlessness that would define British manufacturing for a generation. In September 1967, he launched a hostile bid for AEI, £114 million, and won. A year later, GEC merged with English Electric. When the dust settled, the combined company held almost exactly half of all the turbogenerator business in the country. Weinstock's method was the spreadsheet, applied without sentiment. Across the GEC and AEI operations, redundancies ran, by one account, at more than 30 a working day in the years after the merger. In the House of Commons, Labour members rose to protest that the axing of employees served the shareholders rather than the economic needs of the country. The protests changed nothing. Weinstock was not building an industry. He was rationalising one, and rationalisation has a body count. Parsons saw what was coming and tried to get ahead of it. As the CEGB pressed its two-design policy, Parsons bought the turbogenerator business of GEC, the older GEC, before Weinstock's empire fully formed, taking it over in exchange for a slice of Parsons' own equity. The GEC turbine factory at Erith and the generator works at Whitton were run down and closed, the work brought north to Newcastle. By the end of 1970, 2,000 redundancies had been announced at Erith alone. This is the part that's easy to miss, and important to see clearly. The machine that hollowed out British heavy engineering was already running long before any German company appeared. It was running in the 1960s, and it was British-built, and its logic was domestic. Too much capacity. One great customer. A drive towards scale and standardization that treated thousands of skilled men as a line in a calculation. By the end of the decade, the four firms had become two. Only GEC and a new Tyneside combine could still offer the full range of large turbines, transformers, and switchgear. That new combine was where Parsons had decided its survival lay. To understand it, you have to go back along the river, to Hebburn, and a firm founded by a Frenchman. Chapter 8. The Combine. Earl and Company had been making switchgear at Hebburn since 1886, founded by Alphonse Earl, and by the early 1960s, it was the largest switchgear maker in the world, with some 8,000 employees of its own. Earl and Parsons had been close for decades. Earl had held a stake in Parsons since the 1930s, and by 1967, it owned the better part of a fifth of the company. They were neighbours on the same river, in the same trade, facing the same single customer and the same brutal arithmetic. So, in 1968, they joined. Earl merged with Parsons to form a holding company, Earl Parsons, under its first chairman, Edward Judge. The two famous names were kept. A man could still say he worked at Parsons or at Earl, but the independence that Charles had walked out of Clark Chapman to win in 1889 was now gone. The decision seemed not just reasonable, but necessary. To be one of the two survivors, you had to be big, so they made themselves big. In 1969, the new firm took over Bruce Peebles. In 1974, James Woodison became chairman, and it was Woodison who pushed the logic one stage further. If size was safety, then more size was more safety. In 1977, on his initiative, Earl Parsons merged again, this time with Clark Chapman, the very firm Charles Parsons had left nearly 90 years before, to create Northern Engineering Industries, NEI. It was enormous. Cranes from Clark Chapman, transformers from Bruce Peebles, switchgear from Earl, boilers from the power engineering side, and the turbines still from Parsons at Heaton. At its height, NEI employed something like 35,000 people. On paper, it was exactly what the survival strategy demanded. A diversified giant, too important to fail, spreading its risk across a dozen products. But there was a flaw in the strategy, and it was the same flaw that had been there all along. A bigger company that still depends on the same few customers is not safer. It is merely a bigger thing waiting on the same few orders. NEI had spread its risk across many products, but almost all of those products were sold into the same shrinking pool of British power station and infrastructure work. When that work dried up, size would not save it. Size would only mean there was more to lose. Woodison did not live to see it. He was killed in a car accident in January 1980. Sir Duncan MacDonald took the helm, and then Sir Terence Harrison. These were able men running a well-built company, but the ground was shifting beneath all of them. The warning came in 1988, and it was unmistakable. The order for the Sizewell B nuclear station, the big prize, the kind of contract Parsons had once taken almost as of right, went to GEC, not to NEI. That, together with the drying up of orders for coal-fired stations, put NEI into difficulty. The combine that had been assembled piece by piece, specifically to be one of the survivors, had just lost a fight it could not afford to lose. It needed a parent. And in 1989, a famous British name stepped forward to provide one. Chapter 9. The British owners who walked away. It was Rolls-Royce. This is the fact the popular story tends to forget, and it matters more than almost anything else in the whole sorry sequence. When Parsons lost its independence as a corporate entity, when the Newcastle turbine business passed into the hands of a distant parent that would eventually decide it didn't want it, that parent was not German. It was Rolls-Royce, the most British name in engineering there is. In 1989, Rolls-Royce bought NEI for £308 million. The reasoning was sound, and it was openly stated. Rolls-Royce wanted to grow its position in power generation and to reduce its total dependency on the vagaries of the aero-engine market. Heavy electrical engineering looked like ballast, something steady to balance the violent cycles of selling jet engines. Parsons, the inventor of the steam turbine, became a component of an aircraft engine company, folded into something first called the Industrial Power Group and later renamed Rolls-Royce Power Engineering. For a while, it was simply ownership at a distance. Then the early 1990s recession arrived, and Rolls-Royce did what companies under pressure do. It looked hard at what it actually wanted to be, and it decided it wanted to be an aero-engine company after all. The ballast began to look like dead weight, and then came the decision that, more than any other, reads now like the moment the door closed. In 1996, Rolls-Royce decided to close the steam turbine parts of the business, Parsons among them, for a reason set down plainly in the record. It could not compete with the international leaders, sit with what that sentence contained. The company that had taught the world how to build a steam turbine, the company whose machines had lit the national grid and driven the dreadnought, was judged by its own British owner to be unable to compete with the international leaders in the very technology it had invented, not destroyed by a foreign rival, assessed, costed, and found wanting by a board in England. The world had moved on, and the judgment was not wrong on its own cold terms. Privatisation had broken up the CEGB, the single great customer. The dash for gas was killing demand for the big steam machines. The real giants of the trade now were Siemens of Germany, General Electric of America, and ABB. Parsons, for all its history, no longer had the scale to stand among them. The logic was sound. The logic is always sound. That is what makes these stories tragedies rather than crimes. So in 1997, Rolls-Royce sold Parsons Power Generation Systems to Siemens. Here is where the anger usually arrives, and it is worth being honest about where it belongs. Siemens did not come and take Parsons. Siemens bought a business that its own British parent had already decided to be rid of, a business already detached from the national mission it had served for a century, already stripped of the customer that had made it great, already declared uncompetitive by the people who owned it. The German company was the inheritor of the loss, not the author of it. By the time the Siemens name went up, the hard decisions had all been taken in English boardrooms over 30 years by men who believed every time that they were doing the prudent thing. The proud Newcastle name now belonged to Munich, and for a few years, not much seemed to change. The Heaton Works kept turning, the old hands kept building. It was possible still to believe that ownership was just a word on a letterhead. Then, in the autumn of 2002, the letter came. Chapter 10. The Long Silence. Siemens announced it would cut 400 of the 700 jobs at the Heaton Works by 2004, more than half the workforce, gone in 2 years. The manufacturing would go to Mulheim in Germany and to Budapest in Hungary, where labour was cheaper. The reasons given were the downturn in the world market after the attacks of the 11th of September and the collapse of the American energy giant Enron. Real reasons, reasons no one at Heaton had caused, and no one at Heaton could answer. This was the end of large turbine manufacture in Newcastle, not announced as such, announced as a refocusing, a concentration, a response to market conditions. But that is what it was. Think of what it meant on the floor. The blade shop, where the little aerofoils had been made by the thousand for over a century. The test house, where every machine had been run up under steam and listened to like a beating heart. The drawing offices, the fitting shops, the foundry. The skills that had passed from father to son to grandson on the same site. All of it, surplus now to a calculation made in another country, in a currency the men of Heaton had never dealt in. The work that had defined a quarter of a city was loaded up and sent abroad. There was no single dramatic closure, no final shift with the gates chained behind it. That, in its way, was crueler. A clean ending can at least be mourned. What happened to Parsons was a slow erosion, a draining away, year on year, of the thing the works had been built to do. Manufacturing left, service stayed. The site that had built the most powerful turbines on Earth was now, increasingly, a place that looked after machines built decades before, somewhere else. The numbers tell the shape of it without needing a word added. More than 7,000 people across 100 acres in the 1960s. By the time the cuts of 2002 had worked through, a few hundred remained on a site shrinking around them. The men who lived through it carried the strangest kind of grief, the grief of people who kept their jobs while the reason for the job dissolved. Some of them had started as boys of 16, walking through the Heaton gates into a world that seemed permanent. They had given their working lives to it, and they stood and watched the heart of it leave on a lorry. There would be aftershocks for years. As late as January 2018, Siemens sought further job losses at the old Earl site at Hebburn and voluntary redundancies at the Newcastle Power Services site, blaming fundamental changes to the fossil power generation market. The market had moved again. It always would, and every time it moved, the works grew a little smaller. The cathedral had not been demolished. It had simply, over 30 years, been emptied of its purpose. Quietly, reasonably, one defensible decision at a time. Chapter 11. What the turbines left behind. The works is still there. That is the first surprising thing. On Shields Road, the site that Siemens now calls the C.A. Parsons Works, named, deliberately, in honour of the founder, still stands, still employs around 550 people, but it is perhaps a quarter of its old footprint. Much of the great works has been demolished or repurposed, the ground given over to other uses. What remains does real work, the overhaul and service of turbines, including the old Parsons machines, which Siemens retains the full capability to maintain, renewable energy projects, and the engineering of the electricity grid itself. There is even fresh investment, a couple of £1 million to make control panels for substations, creating some 65 new jobs, riding the wave of a national push to expand the grid for the decades ahead. It is not nothing. It is, in fact, a living industrial site with a future. But it is not what it was, and everyone who works there knows it. The most haunting voices belong to the men who never left. Steve Scrimshaw began his career as a technical apprentice at 16 at the former C.A. Parsons site in Heaton and rose to lead Siemens Energy in the United Kingdom. When I joined Parsons, he said, our site was responsible for manufacturing steam turbine generators. We really were instrumental in bringing power to people all over the world, from Tyneside. Darren Davidson, another former Parsons apprentice, became a Siemens Energy vice president and reflected on it all from the very same office where he'd started, more than 35 years before. Everyone in the Northeast knows the history of Parsons, he said. We've been on this site for more than 125 years. It's up there with the shipbuilding and the steam train. They are right that it belongs in that company, and there is something both moving and painful in the fact that the strongest living testimony to what Parsons was comes from the men who stayed and prospered, while the voices of the 400 who went in 2002 are so much harder to find. History keeps the survivors close and lets the others slip away. And Turbinia? She survived everything. Restored to her 1897 glory, the little steel needle that outran the Royal Navy sits today as the centrepiece of the Discovery Museum in Newcastle, a few miles from the works that built her, perfectly still, behind glass. The fastest ship in the world, at rest. What is a town to make of all this? Heaton still stands. The terraces are still there, the pubs that have survived, the streets that once emptied towards the gates each morning. But the great engine at the centre of it all runs at a fraction of its old power. The men who built the machines that lit Britain were not betrayed in a single act by a single villain. They were let down slowly, by the workings of an industry that decided it had too many of them, by a customer that held all the cards, by defensive mergers that bought time but not safety, and by two British parents in succession who looked at the inventor of the steam turbine and concluded they would rather be something else. Charles Parsons split the fall of the steam into 1,000 tiny steps so that nowhere did it ever move fast enough to do harm. The fall of his company came the same way, not in one catastrophic rush, in 1,000 small, reasonable decisions, each one moving the work a little further from the hands that knew how to do it, until the steam was gone and the test house was silent, and the only Parsons turbine running in Newcastle was one that someone else had built a long time ago and sent home to be cared for in its old age. The machine that taught the world to make electricity was not switched off. It was simply, over the span of a working life, allowed to wind down. And on Shields Road, where 8,000 once clocked on, the silence has a particular weight, the silence of a place built for a thunder it will never make again.